Hi guys, and welcome back to Maths with Cats. So, slightly different video today. Today I am going to be going over a past paper for AQA A-Level Maths. I'm not going to do it all in one go because I want to keep videos 20 minutes. So I've got this little timer here to remind me when it gets to 20 minutes. The full time, if I use the full time, it'll be 6 videos long. For one paper. I don't think I'll take the full time. I don't think I'll do the whole thing in 20 minutes either though. I can't remember what I was going to say. Oh, I'm going to be completely honest with you. I'm going to have my laptop open next to me with the mark scheme on because I don't want to be showing you how to do it wrong. So when I've finished each question, I will be just double checking myself, and I'll pause this so you don't see that on here, and if I need to make any corrections, I will show you. I can't think of anything else to say, so let's give it a go. So we'll press start and we'll turn over the page. So the first question: y equals 1 over x squared. Find an expression for dy dx. Circle your answer. I'm going to show a bit more working than I would in the exam as well, so it makes a bit more sense. So this is equal to x to the minus 2. I'm just checking because I've never filmed this before. So this is the same as x to the minus 2. So dy dx would equal minus 2x to the minus 3, which is the same as minus 2 over x cubed. So it's this one. And yeah, that's correct. Whilst it's just a one marker, I thought I'd just check straight there. So the graph of y equals 5 to the x is transformed by a stretch in the y direction, scale factor 5. State the equation of the transformed graph. So if it's a stretch in the y direction, scale factor 5, we're timesing everything on the right hand side by 5. So it's this one. Yes, that's what the mark scheme says, so that's right. A periodic sequence is defined by un equals sine of n pi over 2. State the period of this sequence. That would be, let's have a think. That would be 4. And that is correct. So if you think about the sine graph, think about, so u of n equals sine of n lots of pi over 2. So if n is 1, sine of, let's change to radians, sine of pi over 2 is 1. If n equals 2, that's going to become 2 pi over 2, so that's 0. 3 pi over 2 minus 1, 4 pi over 2, 0. But we've not got back to the beginning yet. 5 pi over 2, 1. 1, 2, 3, 4. There you go. Okay, so the function f is defined by f of x equals e to the x minus 4, where x is real. Find the inverse function of x and state its domain. So the first thing we're going to do is we're going to say let y equal e to the x minus 4. We're going to then rearrange to get x, so ln y equals x minus 4, ln y plus 4 equals x. So, or therefore, f to minus 1 of x is equal to ln of x plus 4. And it wants us to state its domain. Well, here we are given what was the domain. The original range is what we really want, because the original range is the new domain. So what we're going to do is e to the x minus 4, that has to be more than or equal to 0. So here, f of x is more than or equal to 0. So here, x has to be more than or equal to 0, which you could work out because ln can only be of stuff more than 0. Wait, hang on a minute. I'm just thinking. Ln of 0 isn't possible either. Okay, I'm just going to go with that. Let's have a look. I should have listened to my gut and gotten rid of the equals. That's the only thing that went wrong. Everything else is correct. So, yeah, that's it. Just needed to change the domain I got to x is more than 0 rather than x is more than or equal to 0. Okay, a curve is defined by the parametric equations stated. X equals 4 times 2 to the minus t plus 3 and y equals 3 times 2 to the t minus 5. Show that dy dx equals minus 3/4 times by 2 to the 2t. So for this one, we're going to find dx dt and dy dt. So dx dt is equal to, and that would be, oh, I always struggle differentiating those actually. Let's have a look. Dx dt would be minus 4 ln 2 lots of 2 to the minus t. I did look that up, I'll be honest. I'm not very good at differentiating those ones. Dy dt equals 3 ln 2 lots of 2 to the minus t. Now, dy dx is equal to dy dt times by dt dx, because the dt's will cancel out to make dy dx. And that is equal to 3 ln 2 lots of 2 to the minus t times by 1 over minus 4 ln 2 lots of 2 to the minus t. So first of all, the 2 to the minus t's would cancel out because this would end up on the top and that would end up on the bottom. The ln 2's would cancel out. So let's actually show it. So the 2 to the minus t's would cancel out to give 3 ln 2 over minus 4 ln 2. And the ln 2's would cancel out to give minus 3/4. This one says minus 3/4 times 2 to the 2t. Let's have a think. Oh, I misread this one. This should have been a positive t here and a positive t here. So this couldn't be cancelled out. So that's 2 to the t. This is 2 to the minus t. So you'd end up with 3 ln 2 over 2 to, times 2 to the 2t over that. So this would be minus 3/4 times by 2 to the 2t. That's correct. Find the Cartesian equation of the curve in this form, where a, b, and c are integers. So, for this one, what we need to do, I'm just thinking to myself currently. So, x is equal to 4 times by 1 over 2 to the t plus 3, and y equals 3 times by 2 to the t minus 5. So what I am going to do is I'm going to rearrange one of them to get 2 to the t. So y plus 5 equals 3 times 2 to the t. Y plus 5 over 3 equals 2 to the t. So x equals 4 lots of 1 over y plus 5 over 3 plus 3. So x equals 4 lots of 3 over y plus 5 plus 3. So x equals 12 over y plus 5 plus 3. It wants it in this form. So we're going to times up by y plus 5. So it's going to get x, y plus 5x equals 12 plus 3y plus 15. And it wants xy plus ax plus by equals c. So we're going to go xy plus 5x minus 3y equals 27. So a equals 5, b equals minus 3, c equals 27. Check if I'm right. xy 5x minus 3y equals 27. Correct. Find the first three terms in ascending powers of x of the binomial expansion of this. Okay, so that is the same as 4 plus x to the minus a half. So what we are going to do, I do not have my formula book here, so let me just look one up. I should have got this ready. I'm going to pause it whilst I do this. Okay, so I've got my formula book up on my laptop. So there's multiple ways to do this. My way is to make it, how do I explain this? 1 plus x to the power of something multiplied by something. So I'm going to say this is equal to 4 lots of 1 plus x over 4 all to the minus half, which is equal to, well, what's 4 to the minus a half? That is a half. So half of 1 plus x over 4 to the minus a half. And then what I'm going to do is I'm going to use the formula 1 plus nx plus n lots of n minus 1 over 2 x squared, etc. So that's equal to a half of 1 plus, and the n is the power, and then the x is the entire x term. So we want nx, so we're going to do minus a half times by a quarter. So that's going to be minus 1/8 x plus minus a half minus 1 over, and this is actually 2 factorial, but that's just equal to 2 lots of x squared, but it's x over 4 squared in our case. And it's the first 3 terms. That would give us the first 3 terms. So that is equal to a half of 1 minus 1/8 x. Then we'll work out what this is. Minus a half, lots of minus a half minus 1 equals divided by 2 equals times by 1/4 squared. So that's plus 3 over 128 x squared. And then it's all times by a half, so a half minus 1/16 x, and that divided by 2, plus 3 over 256 x squared. Let's check the mark scheme. Half minus 16 plus 3 over 256. I am correct. Hence find the first 3 terms of the binomial expansion of this. So all you do, everywhere where there's an x in this, we're going to replace it by a minus x cubed. So a half minus 1/16 of minus x cubed plus 3 over 256 minus x cubed squared. So a half plus 1/16 x cubed, and then that's going to be plus 3 over 256 x to the 6. The minus times by itself gives a positive, which is why that doesn't have a negative. Let's have a look. Half plus x cubed over 16 plus 3x to the 6 over 256. Yep, that is correct. use your answer to part B, find an approximation for this, giving your answer to 7 decimal places. So this is going, basically because we're approximating, we can use the binomial expansion for what we've done. So integration between 1 and 0 of a half plus x cubed over 16 plus 3x to the 6 over 256 dx. That's what we want to do. It's the same thing. Well, no, it's not. It's roughly the same thing. Okay. And then this is equal to, and we're going to put our square brackets. Half integrated gives half x. This integrated is going to give, we're going to have an x to the 4, but we're going to divide the whole thing by 4. So it's going to be plus x to the 4 over 64. And then that's going to increase to 7. So 3 over 256 divided by 7. So that's going to be plus 3x to the 7 over 1792. And that's going to be between 1 and 0. So then we're going to sub 1 and 0 into each of these things. So that's going to be a half plus 1 over 64 plus 3 over 1792 minus, and that's going to be 0 plus 0 plus 0 is equal to, and I'm going to type it in our calculator, a half plus 1 over 64 plus 3 over 1792 is equal to 927 over 1792. And what is that as a decimal? That is the same decimal they've given us. I don't quite understand why they... Oh, it says to give it to 7 decimal places. So that is equal to 0.51729991 to 7 dp. Okay. Edward, a student, decided to use this method to find a more accurate value for the integral by increasing the number of terms in the binomial expansion used. Explain clearly whether Edward's approximation will be an overestimate, an underestimate, or if it's impossible to tell. Each of these terms is getting smaller, so it will be... What do you think? Each is just getting smaller, but the overall number is increasing every time, just by a small amount. So it's going to be an overestimate as each term is positive. Let's check. Each term in the expansion is positive, so increasing the terms will increase the estimated value, hence the value must be an underestimate. Oh, other one. Under. It's an underestimate because until you get to the infinity of term, you're not going to get the exact number, of course. Edward goes on to use the expansion from part B to find an approximation for this. Explain why Edward's approximation is invalid. Well, if we go back to the formula book for what we used, the expansion is only valid for the modulus of what would it be? Hang on a minute. So that would have been quarter x and then because it was cubed, a quarter x cubed. So for the modulus of x cubed over 4, oh, it became negative as well, is less than 1, which is the same as minus a quarter x cubed is between minus 1 and 1. I don't know why I've done that. That should not be equal to. Which is the same as x cubed is between minus 4 and 4. But because we were timing it by minus 4, this one actually gives the positive 4, and this one gives the negative 4, but it ends up being the same because signs switch when you times by a negative. And then the cube root of minus 4 is minus 1.587401052, and 1.587401052, and minus 2 is outside of this range. See what the math scheme says. I think there's multiple ways to explain this. I don't know. Yeah, that works. Yeah, alright. Okay, so we're going to leave that there. I got through 6 questions that time, so that's not bad. I hope you found this useful. Please can you like and subscribe, possibly even give me a comment, just to increase the chances of other people coming across this video and getting help. Thanks for watching, and I hope you will watch me again in future. Bye bye!